And the next topic is the future of artificial intelligence. We do that with a professor from the University of Eindhoven, Rob Wolfs. I hope Rob is also already online and with us. Yes, he is.
Good afternoon.
Hello,
Hi,
good
Rob.
afternoon.
Yeah.
How are you?
I'm fine, thanks.
Well, it's great to have you with us. I'm really looking forward to your keynote about the artificial intelligence impact in our industry.
All right, thank you, Wouter. Let me see if I can share my screen.
Yep.
There we go.
Yeah,
Okay.
that works amazingly. Thank you.
Great. So, good afternoon, everyone. Thanks for having me. It's a pleasure to share my vision on what our construction industry could look like in the future. And today, first, I would like to address briefly why I think our industry needs to transform, and then show you a few of the research challenges that we are addressing at our university in Eindhoven to make this future a reality. So let's start with the question why. And to do that, I would like you to take a look at these two pictures. On the left, you can see what a typical manufacturing process in our industry looks like. And on the right, you can see a manufacturing process in another industry, like the automotive industry, for instance. And if you compare these two pictures, then it doesn't come as a surprise that the construction industry is known for its low productivity and a low level of innovation. And although not immediately clear from this picture, it is also known for a high environmental impact. And you could say that the material on the left is part of the reason for that. If we then look at the image on the right, we see an industry that has transformed itself over the past years. It has increased its productivity, optimized its processes, and also allows a reduction of material use. And in this transformation, the adoption of digital technologies has played a central role. And I believe that this digital transformation can also provide an answer to the productivity and sustainability challenges that we face in the construction industry. And it is for this reason that at our Department of the Built Environment at TUE, we study these digital and novel technologies to see what they can mean for our industry and also to address the research gaps. In the design phase, that means we, for instance, adopt digital twinning or parametric modeling, topology optimization, advanced numerical simulations, and so on. And you might say that some of these tools are not new anymore. And that's actually good news because that means we are already applying them in practice. But what we are also doing is bridging the gap from digital design to digital manufacturing as well, and use robotics for construction. For instance, for automated assembly, as you can see in this student project here on the right, but also automated CNC milling or even weaving of objects. Now, all of this digital design and digital manufacturing development comes together in one of our main research topics, which is large-scale 3D concrete printing. In the laboratory of our department, we operate this 3D printer, which is able to print objects on a scale of buildings and bridges using concrete. We've been doing this for quite some years now, and together with various industrial partners and also municipalities, we have realized some first large-scale objects. And we've completed these projects on the one hand to illustrate the potential of this digital transformation of our industry, showcase the advantages, but on the other hand also to learn what are still the main challenges we have to solve for a widespread adoption. And one of the main points that we learn here is that we have to change the way we operate. We have to move from a very fragmented and sequential way of working to an integral one. where we consider the design, so what we make, the materials that we use, and also how we make it, and in this case 3D printing it, as one integral system. Now, in our research group, we study these different topics, and even more so the connections between them. So for instance, we develop new types of materials that are printable with a lower ecological footprint or with more functionalities, like you can see in the bottom left. That also means we have to upgrade, we have to develop our robotic systems, our printer, to be able to print different materials on demand on the right spot. And also, for instance, integrate reinforcement, as you can see in the picture on the top left. Now, these new materials and this printing technology then come together in the designs that we make. And for that, we develop optimization algorithms that allow us to design objects that consider the possibilities, but also the limits of the manufacturing technique and those of the materials. And on the top right, you can see an example of such an optimization strategy that defines where we have to place the material in the most efficient way, considering what the printer can and cannot do. Now, all of that then comes together in these large-scale projects, like the 3D printed house that you can see on the bottom right, which you might have seen coming by in the news recently because it was opened in Eindhoven just a while ago. Now, so far, so good. We are developing these technologies and showcasing the potential in first projects. But you can imagine that as the objects are becoming more and more complex, the geometry, the freedom in geometry is also a challenge. The materials that we use are more and more advanced and may even vary throughout an object or throughout a building. And the robotic system that we use also becomes more and more complex because we are printing multiple materials and adding more steps and so on. You can imagine that this complexity for a human operator to control or even optimize will be very difficult, especially when we aim to move these systems outside on the building site to produce locally on-demand objects in uncontrolled conditions like weather and wind conditions. And while I'm saying this, it immediately starts to pour outside. And what about structural safety? We are used, at least as structural engineers, to check the structural integrity by means of, for instance, the Eurocode, where the safety is covered by based on decades of experimental research and information on conventional structures. But now we are applying new types of materials in complex geometries using a new manufacturing technique. And in that case, maybe all of these rules, they may not be enough. But we do not have the time to build up decades of experimental tests for this new technique, because we won't be able to answer the environmental challenges or the housing deficit in time for these new techniques. Now, for all of these reasons combined, the use of artificial intelligence will play an important role in our construction industry. We can combine models, simulations for predictions, and data that we gather during the manufacturing process, during printing, but also of the environment and also of the objects that we make by integrating them with sensors and so on. And we combine these two sources of information and use it for optimization of the manufacturing process and even of the design of the objects that we make. So, in short, our industry is facing some serious challenges related to its productivity and its sustainability. And I believe that we need to embrace this digital transformation and apply the use of artificial intelligence in our industry, which will allow us to create more efficient buildings and build them in a more efficient way. This is me in a bridge that I 3D printed a while ago, and my contact details are there. So if you want to reach out, feel free to do so. Thank you.
Well, Rob, thank you very much. That was an amazing insights in the future of construction and the future of artificial intelligence. Happy to have you with us. We need to move on as fast as possible to the next panel, but I hope to speak to you soon because we're going to visit Eindhoven one time to also go to Theo Salet and see what he is doing. I saw also some pictures of you from you in your presentation in there about what he's doing on 3D printing. So thank you very much.
You're welcome. Thanks for having me.
Have a great day.
Bye-bye.